First one is talking about two chords inside of a circle. They're going to put a number here and they're going to put an X there. And they're going to put a number here and a number here. And they're going to say find X. As you can see here, we simply multiply the parts of the chords together and set them equal in order to solve. So piece of cake. So in order to solve this mini problem that I have here, you would say 6x is equal to 12. 6 times x is equal to 3 times 4.
Okay,
I went ahead and multiplied that out. You're just multiplying those values from here to here times here to here.
Okay, so it's not an angle.
You're doing the lengths of the segments, correct. This is, I didn't say that, this is 6.6 circle segments. Segments in circles. Okay? So I would divide both sides by 6 and x equals 2. Okay? Piece of cake. Questions? Now, how does this problem get a little harder? Is when they start putting a little bit more algebra into it and they say something like this. 6 and x plus 1 and 3 and x minus 2. For some reason, when I put in x plus 1 and x minus 2, people totally forget that all I'm doing is taking that amount and multiplying it by that amount. And I'm taking that amount and I'm multiplying it by that amount. Exactly the same thing I did on the previous problem, I do here. So I would say 6 times x plus 1 equals 3 times x minus 2. I don't know if that works out to a nice number. Hello? I do? Okay. Thank you. All right. The assignment's underneath the football player over here. All right. So here we go. 6x plus 6 equals 3x minus 6. I get 3x over here. I subtract 6 from both sides. I get negative 12. And x equals negative 4. Typically, you won't come up with negative answers. That's just because I made it off the top of my head. But you get the idea. Okay? Very, very important to put the parentheses and make sure that you do what? What is this called? Distributing. You must distribute if you want to get the problem correct. Okay? Put parentheses and make sure that you distribute. Okay? Questions? Any questions on that procedure? All right. Let's do the next one. Here we go. What kind of lines do we have now? Instead of chords, what do we have? We have two secants. Please don't do that. Break the chair. I've seen it happen and it stabs you in the back. So here we have two secants. All right, and this is very important. We have an outside part of the secant, and we have the total length of the secant from there to there. The same thing is true on the other one. We have an outside part, and then we have a total part from there to there. Okay? So this is the total, and that's the total, outside and outside. Why is that important? Well, if you look, this is outside O times T. Outside times the total. I'd write that down in my notes. And the other side is outside times the total. It's always going to be outside times the total times outside times the total. I'm going to do an example here in just a minute. I'm going to let you write this down. Correct. And the outside part is the outside part of the segment. The secant that lies outside of the circle. The total is the total length from there to there. From E to D. The total length. Okay? All right, you ready for an example? Let's see. right, number 13, here's a good example. Don't let it go over 10 minutes. If you need to stop it, let me know. All right, so here we are, number 13. We've got two secants. We have an outside part and an inside part, an outside and an inside. We'll do the easy one first. 4 is going to be multiplied by what? That's wrong, and that's the common mistake. It's 4 times the total. What is the total from here to here? 11. Okay, copy this example down in your notes so that you don't make that mistake. It's not 4 times 7. It's the outside times the total. How did I get 11? I said 4 plus 7 to get 11. Laura?
Okay, what are the numbers?
X, 3, 4, and 7. Okay? Equals on the other side. Okay, obviously that's going to be 44. What am I going to get on the other side? Well, I get an outside part, and then I got to get the total. What is the total? 3x. When I add x and 3, I don't get 3x. When I add 3 and x, I get x plus 3. How important are the parentheses? Very important, right? Why? So you know to distribute. And somebody asked in second period, how do I know to put the parentheses? Anytime you have x plus 3 or x plus 5 or whatever, you better be putting parentheses. So make sure that you know to distribute. So I distribute here and here, and what do I get? 3x plus what? Plus 9. I subtract 9 from both sides, and I get 35 equals 3x, and I get an ugly number. Why? X equals 35 over 3. An ugly number because 3 won't go into 35. I don't know why they did that, but you get the idea. If it said round like money, you would round like money. Okay? Questions? All right, now that we've done one of them, let's do 15. And then we'll do the next theorem. How do we do 15? Set it up for me, Corey. Oh, wait a minute. What's different about 13 and 15?
The X on the outside.
X is on the outside. It's a little different. Okay? It's not impossible. It's just a little different. Let's set up 14 and do an easier one, and then we'll do 15. Set up 14.
6 times 10 equals 5.
Just X. Right? Don't they tell you that the total is X? It's totally different than this one.